Okay, so in this video we're going to be working on the day 3 warm-up. We've got two questions here, one over work and power, and then one over the conservation of mechanical energy, so you can get just a little bit more practice before your quiz. Okay, so question number 1 we'll do first. Okay, so of course try to answer the questions on your own first. Question number 1 says a motor attached to a harness is used to lift a 6-kilogram cat. Okay, so this is a piece of given information. Look at the unit, kilogram, that's the unit for mass. Okay, so we have the mass of the cat, which is a pretty heavy cat, by the way. And it's used to lift the cat up off the ground to a height of 8 meters. Okay, so this is going to be either a distance or height, depending on what we're asked to find. Obviously, it says height, but if it's lifting the cat straight up, that also means that the cat moves a distance of 8 meters. Okay, so depending on what we're asked to find, this could be height or it could be distance. Okay, because they would be the same in this case. Now, the motor takes 4 seconds to lift the cat, so this is time. Now, the first question says calculate the work done in lifting the cat. Remember that work is force times distance. Okay, and the force to lift something has to equal the weight of the object, which is the force of gravity. Okay, so we need to find the weight of the cat. So we would multiply the mass, which is 6 kilograms, times the acceleration due to gravity, which has a value of 10 meters per second squared, to get a force of 60 newtons. And so when we get to plug in to the equation, which we'll do right here, we would plug in the force, which is 60 newtons, that's the weight of the cat, times the distance of 8 meters, okay? And so you should get 480 joules. Okay, remember work, so 480 joules. So work is not energy, but it's the transfer of energy, and so it has units of joules. 1b says calculate the power of the motor, which is used to lift the cat. Well, power is work over time, right? That's how quickly energy is used up. And so that would be 480 joules, which we just found, divided by the time of 4 seconds. Okay, and so that would be 120. Remember, the unit for power is watts. Okay, capital W, not confused to be, or not to be confused with the W for work. Okay, so question 1A, 1B, that should be a review question by now. That should be pretty simple. Pause it there if you need to take a look at that. Okay, so I'm going to erase this. And then let's take a look at question 2. So question 2 says a rocket is launched up into the air at 120 meters per second from an initial height of 80 meters. Calculate the maximum height reached by the rocket. Hint, use conservation of mechanical energy. Okay, so try to answer this question on your own if you can. So let's start, maybe a picture might help. Now, I cannot draw a rocket very well. So I'm just going to draw like a box to represent the rocket, maybe some engines at the bottom. And basically the rocket is going to start off, and then it's going to go up, 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 up into the air. And then at its maximum height, we saw this a lot in the last semester, when an object reaches its maximum height, it stops moving. Okay, that's why that's its maximum height, because if it was still moving, it would have kept going up. So this is the initial position. This is the final position. Now, it says the rocket is launched up into the air at 120 meters per second from an initial height of 80 meters. Okay, so that means down here, the height of the rocket, the initial height, which I'm going to label HI, is 80 meters, and 120 meters per second, looking at the unit, I know that's got to be speed or velocity. And I know it's the initial value because that's how fast it's moving at that initial height. So that's going to be my VI. Okay, so I'm just labeling everything that's given. Okay, now what is my unknown? It's asking me for maximum height, but remember, when an object reaches its maximum height, it stops moving. You have to understand that to answer this question, because at the maximum height, that means the velocity there is 0 because it stops moving. Okay, if you don't know that, there's no way you can answer this question. Now, what is our unknown? Well, we're looking for height. Okay, so that would be the final height. And we're told to use conservation of mechanical energy. Remember, the idea behind mechanical energy conservation is that the mechanical energy, which is the kinetic plus potential energy of an object is basically a fixed value as long as there's no friction or air resistance. And when I say it's a fixed value, that means we can write it like this, that the initial value is equal to the final value. So I'm going to take this equation and I'm going to expand it out. For the initial mechanical energy, I'm going to write 1/2 mvi squared, that would be the initial kinetic energy, plus mghi, that would be the initial gravitational potential energy, is equal to, I'm going to write the same thing on the right side, 1/2 mv final squared plus mgh final. Okay, just like this. So basically I'm just plugging in the definition of mechanical energy into this equation right here. Okay, remember kinetic energy plus potential energy, that's what mechanical energy is. Okay, so now that I'm down to this point, I'm going to plug in my numbers. Now, notice I am not given the mass of the rocket, so I will give you a mass. So let's say the mass is 1,000, although I will tell you, just to be honest, that the mass really doesn't matter. Because there's a mass in every term in this equation, it's going to cancel out anyway, and so the mass actually doesn't change the answer to this question. But, you know, if that messes with you, let's just say the mass is 1,000 kilograms. It's not going to make any difference anyway. Okay, so now I'm just going to plug my values in. Okay, so I have 1/2 times 1,000. Okay, remember I'm using 1,000 for my mass, not that it matters, times V initial, which is 120 squared, plus the mass of 1,000 times g, which is the acceleration due to gravity. Okay, so that's 10, and the initial height is 80, and that's equal to, okay, now remember, at the maximum height, it stops moving. Okay, that's really key to answering this question. If you don't know that, you can't answer this question. Because it stops moving, it has no kinetic energy at the highest point. That means this whole term is going to be 0, because remember, kinetic energy is energy of motion and it stops moving at the highest point, plus 1,000 times 10 times h final. Okay, and so now I'm just going to simplify. Okay, I'm going to use my calculator to simplify. Okay, so 1/2 times 1,000 times 120 squared. Okay, I get 7200000. Okay, so 720,000, or sorry, 7.2 million. Okay, plus 1,000 times 10 times 80. Okay, so that would be 800,000 equals, okay, I don't care about the 0. 1,000 times 10 is 10,000, so that's 10,000 times h final. Okay, and so all I need to do is I need to add these two numbers. Okay, and so that is going to be 8 million. Okay, so 8,000,000 equals 10,000 h final, and then the h final is multiplied by 10,000. So to undo that multiplication, I need to divide both sides by 10,000. Okay, so I divide both sides by 10,000. I divide both sides by 10,000. Okay, and I get h final equals, let's see, just canceling these zeros out. Okay, 800 meters. Okay, and so that is the answer to my question. Now, if that seems like really high to you, well, 120 meters per second is like 250 miles per hour. Okay, so it should make sense that, you know, that it goes pretty high up. All right, so please let me know if you have any questions, and I will see you guys in the next video.